Welcome back, Wolfpack. Today's topic is perimeter and area of figures on the coordinate plane. And hopefully by the end of today's lesson, you'll be able to find the perimeter and area of figures on the coordinate plane. To find the perimeter of a figure, you need to find the lengths of each side, and then you add those lengths together. Right? So if, for instance, if I have a triangle, and this is 3, and this is 3, and this is 5, simply add them up together, and that's the perimeter. Okay? So perimeter, no matter how many sides it has, you add up all the sides together, and that's the perimeter. To find the area of the shape, you need to find the length of the bases. You need to often know the height, or you need to know the length of the diagonals. So to find the area of a shape, you're going to need to know one of those three things. Okay? Area formulas. These are formulas you should be pretty comfortable with and have seen over and over and over again. You have to know these. Some of these may be on the FSA reference sheet, but it's possible not all of them will be. So first up, a triangle, okay, is 1/2 base times height. So 1/2 times the base times the height. And remember, we know since we're working with multiplication that whenever we have letters like that, that means it's 1/2 times base times height. And since we're doing all multiplication, we can just write the letters right next to each other. Okay? So 1/2 of base times height. So base right here, height right here. Okay? The base and the height are perpendicular to each other. A rectangle is simply the area of, the length of the base times the length of the height. Okay? Parallelogram, you need to know the base and you need to know the height. And again, the height has to be perpendicular to the base. So this, the blue part, is not the height. Okay? The slanted is not the height because the height has to be perpendicular to the base. Okay? Hopefully that makes sense. Oh, my bad. Let me erase that. We'll try this again. Okay, so the base, the height, base and height are perpendicular to each other. Rhombus. For a rhombus, the formula is 1/2 of diagonal 1 times diagonal 2. Diagonal 1, diagonal 2. It doesn't matter which one you call diagonal 1 and which one you call diagonal 2. You multiply them together and cut them in half. And it's the same exact formula for a kite. Diagonal 1, diagonal 2 multiplied together times 1/2. Or diagonal 1 times diagonal 2 cut in half. So rhombus and kite, as you notice, are the same exact formula. And then lastly, trapezoid is slightly different. Trapezoid, you add the two bases together and multiply it by the height, and then multiply it by 1/2, or say cut it in half. So base 1 plus base 2 times the height cut in half. And again, notice the height is perpendicular to the base. So really you only have four formulas here that you have to know. Triangle, rectangle, and parallelogram, which are the same. Rhombus and kite, which are the same. And then trapezoid. So let's put some of these into action. We're going to do example 1 in class, but we can do example 2 right here. So example 2 says find the area of the trapezoid. Looking back at the notes, the area of the trapezoid is 1/2 base 1 plus base 2 times height. Okay? So 1/2 base 1, which is 2, plus base 2, which is 1, 2, 3, 4, times the height, which the height is a straight line that's that's perpendicular to the bases. So this would be the height. Okay? So 1, 2, 3. Okay. 1/2. 2 plus 4 is 6 times 3. So 6 times 3 is 18. 1/2 of 18 is 9. So the area of the trapezoid is 9. Simple, straightforward, easy to find on a coordinate grid. Find the area of the kite. The formula for area of the kite was area of the kite is 1/2 of diagonal 1 times diagonal 2. Diagonal 1, 1, 2, 3, 4, 5, 6 pieces. 1/2 times 6 times diagonal 2. Okay, from point to point. 1, 2, 3, 4. 1/2 of 24. Half of 24 is 12. Okay, these are all straightforward problems. The picture is right there. I knew this was the diagonal because it was from vertex to vertex, and this is the diagonal from vertex to vertex, and I was able to simply count. Okay? And one more problem, we're going to do example 4a, find the area of the triangle. This one may look a little tricky, but it's honestly not. The area of the triangle is 1/2 of base times height. Now, this shape looks weird because it's sideways, but if you were to turn it, let me see if I can turn it so you can see. Well, let me turn. Aha, there we go. Okay? So if I turn it, it's easier to see that this is the base. 1, 2, 3, 4, 5, 6, 7. So a nice straight line is the base. And then I can count the height from one vertex down. It's perpendicular. 1, 2, 3, 4. So 1/2, 28, and voila, 14. Because that one's on a coordinate grid with a nice straight line and a perpendicular height, you're able to easily find it. Okay? Don't get confused because it's sideways. You can turn it back this way, and it's still there. Okay? The base would be the nice straight line, and the height would be from the vertex to the base. Okay, even though it's sideways. We're going to do letter B in class because, as you can see, that triangle doesn't have a nice base that's perfectly straight on the coordinate grid. But when everything lines up nice in the coordinate grid and you're able just to count, you can easily find the perimeter area of shapes. So as a recap, that's what we're doing next class, finding the area and perimeter of shapes. You will need to know these formulas, something you can't just not know. You have to know them in order to be able to perform the calculations. Hope you have a great day and a great evening, and I'll see you guys next class.